Zeal Education Society, redefining excellence.
Hello, I am Dr. Mahadev Unde, Zeal College of Engineering, Pune. In the previous video lecture, we have learned the alternating current flowing through pure resistance, pure inductance, and pure capacitance, and their behavior in terms of their equations, waveforms, phasor diagram, and power consumed. In this video lecture, we are going to learn alternating current flowing through RL series circuit. We have to obtain the current expression, the waveforms, phasor diagram, impedance triangle, and power equation. So let us start. The alternating current flowing through RL series circuit. I am drawing the series circuit. Resistance and inductance are connected in series. This is R, this is L, current is I RMS, voltage is phi RMS, then voltage drop across, resistance is phi R, and voltage drop across, inductance is phi L. Therefore, the supply voltage phi equal to phi R plus phi L. Note that in AC circuit, it is a phasor addition. However, in DC circuit, you can take the arithmetic sum. So here, we can write let I RMS value of alternating current phi RMS value of supply voltage phi R equal to I into R, voltage drop across resistance in phase with current I. Then phi L equal to I into XL equal to voltage drop across inductance ahead of current by pi by 2. Phasor diagram. Now here in series circuit, current flowing through each element remains same, and therefore we will consider current as a reference vector. So this is a current as a reference vector. Then voltage drop across the resistance phi R is in phase with the current. Say this is A, this is phi R. Then voltage drop across the inductance is ahead of the current by pi by 2. That means current is lagging the voltage by an angle pi by 2. So here it is B and this is phi L. And when you join this is phi, this is the resultant, and angle made is phi. So from this, phi is the supply voltage, I is the resultant current, and therefore the resultant phasor diagram will be This is current I. This is phi. So if you observe carefully, current lags the voltage by an angle phi. So how to observe it? By this way. Its same can be written as, by considering voltage as a reference vector, say this is phi, then current will be here. So every time current is lagging the voltage by an angle phi. So here current lags the voltage by angle phi. So we can make the conclusion, whenever alternating current flows through the inductive circuit, RL circuit is an inductive circuit. The current lags behind the supply voltage by an angle phi. Now using the triangle OAB, phi equal to, or phi square equal to phi r square plus phi l square. This is equal to, phi r is nothing but I into r bracket square plus I into xl bracket square. Therefore phi equal to square root of IR square plus IXL square. Taking I as a common, remainder is R square plus XL square. So therefore I equal to phi upon z, where z equal to square root of R square plus XL square ohm. Its unit is ohm and known as impedance of the circuit. Impedance of the circuit. Now the impedance triangle. See the impedance triangle. Now this here is nothing but I into R. So OAB angle phi, phi R equal to IR, phi L equal to IXL, and phi equal to IZ. Now the current is common everywhere, and therefore the remainder circuit becomes, remainder is the impedance triangle, that is OAB. This is XL, this is R, this is Z, angle is phi. From this impedance triangle also, Z equal to square root of, using Pythagoras theorem, R square plus XL square. Also, power factor equal to cos phi equal to R upon Z. Therefore, R equal to Z cos phi. Similarly, XL equal to Z sin phi. Then this can also be written as Z equal to R plus JXL equal to Z mod angle phi. That is, this is rectangular coordinate, this one is polar coordinate. Now here we can draw the waveform. Or otherwise from this we can write like this, I equal to I equal to phi upon z. Let phi equal to phi angle 0 degree. This is z angle 5 degree. And this is equal to the ratio of phi by z is I mod angle minus phi lagging. So I equal to mod I angle minus phi. Minus sign indicates that current is lagging. Okay. Then we have to see the waveform. We are going to learn both the waveforms. Now from this, if phi equal to phi max sin omega t is the supply voltage, then current small I equal to I max sin omega t minus phi. So this is the voltage equation and corresponding current equation is this one. If you compare these two equations, the voltage equation omega t plus minus 0 indicate that this is the reference starting from the origin. Whereas the current is lagging and here it is sin omega t minus phi indicates that this waveform will start from right of the origin. Therefore, see, this is 0. This is the voltage expression. This is phi. Now current expression will start somewhat here, right of the origin by this much deflector. So similarly you have to mark it and say that its magnitude is little bit less. As compared to voltage, and this will be here. So this angle is phi. This angle is phi. This is the current expression. And current equal to I max sin omega t minus phi. Now the power expression we can draw from this. See, in between this and this, if you draw the line here, in this band, current is negative, voltage is positive, and magnitude is small, and therefore the resultant is small. Now in this band, both current and voltage are positive, their product is positive, their magnitude is also large. Then within this small band, the magnitude is, current is positive, voltage is negative, their product is negative. Now once again from this to this point, both voltage and currents are negative, their magnitude are large, and therefore their product will be also large. So it has, this is positive and this one is negative. This is the power waveform equal to P max, I max, sin omega t minus phi. So the average power by subtracting this much amount from this, you will get the average power. This is average power equal to phi I cos phi. So we have to obtain the power expression from this, and we know that the power is given by phi I cos phi, but we have to obtain it. So let us consider the power expression. Now let V equal to V max sine omega t, then I equal to I max sine omega t minus phi, equation 2. Therefore, instantaneous power small p equal to small v into small I equal to phi max I max sine omega t into sine omega t minus phi. Now this is as good as sine A into sine B. And therefore its formula will become, this will be phi max I max upon 2 into bracket. This is cos A minus B, means this will be cos phi minus cos of A plus B is twice omega t minus phi. Therefore this is equal to phi max I max upon 2 into cos phi minus phi max I max upon 2 into cos of twice omega t minus phi. Now the power has two components, two parts. The first part is fixed part. It has no time component. It does not vary with time. Whereas it has a time component. It is pulsating in nature. It varies with time. So this is varying or pulsating component. Now its value, the value of second part, pulsating part, over a complete cycle is 0. So this goes to 0, second part. Over a complete cycle means we have to take the integration from 0 to 2 pi. The value of second part is 0, and therefore the average power, now the P equal to phi m Im by 2 into cos phi. This can be written as phi m upon root 2 Im upon root 2 into cos phi. Therefore P equal to phi RMS I RMS into cos phi. So in this way, this is the expression for power. This expression, if you consider carefully, P equal to phi, we can write this is I equal to phi I and cos phi is r upon z. So what is this one? This is nothing but current. So this is current I into R. So it is I square R. So P equal to I square R. Right. Now this is because the circuit consists of resistance and inductance, and we have already studied that the inductance does not consume any power and power is only due to resistance, and therefore P equal to I square R or P equal to phi I cos phi. This is the general expression. So, and also we have studied cos phi etc. Now let us have a symbolic notation by symbolic notation. Okay, that has been already considered. That has been already considered. So, what is the conclusion from this? Whenever alternating current flows through RL circuit, RL means inductive circuit, current lags the voltage by angle phi. Therefore, power factor equal to cos phi is lagging. Power factor is lagging, current is lagging, and current expression is mod I angle minus phi. This minus phi indicates that the current is lagging. So, in this way, we have obtained the expression for current, then the expression for impedance, expression for power factor, and expression for power. Now we have obtained the instantaneous power. However, this power can also be obtained by other way. Say this is the current as a reference factor. See, this is phi. Now this is phi. Resolved current into two components. This is I. This angle is phi. This component, and this is I cos phi. This is I sin phi. So I cos phi, active component of current, also known as is also known as wattful component. And I sin phi, reactive component of current, or phase quadrature current. Quadrature means 90 degree. Now this active component of current, it is in phase with phi. It is in phase with phi. It is in phase with voltage phi, and this is phase quadrature with voltage phi. So this component I sin phi is perpendicular to the phi, and I cos phi is in phase with phi. Therefore, the active power capital P equal to voltage multiplied by active component of current. So P equal to phi, and active component is I cos phi. Unit is watt or kilowatt or megawatt. Then second, reactive component, reactive power, denoted by Q. It is voltage multiplied by reactive component of current. So Q equal to phi I sin phi. Phi AR or K phi AR or M phi AR, bigger units. Now say this can also be written as, just now we have seen I square R. Now this Q can also be written as, see what is sin phi? Sin phi is from the impedance angle, it is R upon X upon Z. X upon Z. So Z is nothing but I. So it is phi I XL upon Z. So phi upon Z is I. So it is I square XL. Third point, apparent power. S. It is the product of voltage and current. So S equal to phi into I. This can also be written as I square Z. Unit is phi A or K phi A or M phi A. Therefore, its angle can be drawn like this. OAB. This angle is phi. This is P. Horizontal component is P. Vertical is Q. And this is S. Therefore, power factor equal to cos phi equal to R P upon S. And S equal to square root of P square plus Q square. So in this way, we have studied the active power, reactive power and apparent power. And we have studied the power triangle also. This is the power triangle. So students, we will stop here.